Hi everyone, welcome to our next video for topic 21. This video is on composite figures and shaded regions. So what do we mean by that? Well, we have shown you some basic polygons, right? And some basic shapes like circles. But what if I give you a shape that is not so basic, right? Because obviously not everything in the real world can be solved with just an equation right off the bat, right? So for example, what if I had said, okay, I got a room that has got the square bit right here, then it opens up into a kitchen, right? And then I've got my foyer, which is, a circle, right? So we'll say it's like this. It's a semicircle. Not a very well drawn semicircle, but you get the idea. Goodness, drawing a circle's hard, right? And then I've got this little nook right here with like shelves and stuff. How do I find the area of that shape that I just constructed? Yeah, right? Not so easy. There's no equation for this. I'm not going to tell you, oh, this is called a grabogapazoid, right? It's not. This is some shape that exists in the real world, maybe, right? Not very convenient to find the area of, is it? Well, again, you could just count off the squares, but then you got the circle bits. You cannot count off the squares for these, right? How do we do it? This is what's called a composite figure. Composite figures, that word composite might look familiar, right? Composite means to put together, if you remember, like a composition of music or a composition notebook, putting together all your notes, right? So these are figures made up of other figures. If you look at this picture, I want you to think about this, maybe even doodle on your screen a little bit. How would you break this down into basic shapes? What basic shapes make up this? Think about it. Pause the video. All right, hopefully you paused it and you considered what basic shapes make this up. I'll show you what I did. There's different ways to do this, many different breakdowns. I'm going to do it like so. I've got this square, right? I did describe it as a square in the beginning. And then I've got this rectangle. Notice I didn't construct it as a rectangle. I did a rectangle offshoot over here, then another rectangle over here, and a square below. But I'm going to put it all together as one big rectangle. And then I've got my last bit on the bottom here, which is not a whole circle, but what we call a semicircle, right? So we'll need to do a little bit of thinking there to figure out the area of that. How do I find the area of this composite figure? Well, what if we just found the area of each of the figures that make it up, right? Because we know the formulas for those. So I'm going to take some measurements here. I've got 3 by 3, right? And then down here, I've got 3 by, this is 2, and this is 1, right? And then I've got my circle bit on the bottom, not really a circle, more of a semicircle, right? And I'm going to tell you that this right here is, actually, I won't tell you that. We did know that this right here was 4, right? So how would I find the area of everything? Well, we can start with the thing that's pretty easy, the square, right? I know that the area of the square bit is 3 times 3, right? And that's going to be 9. So if I said this is measured in yards, let's say, right? Everything's in yards. Then that's going to be 9 yards squared. Okay. Remember to use your units, right? Units are very important. If I give you units, you want to put your answer in units. And if it's area, it needs to be squared, right? What about the rectangle? Well, I've known that the height of the rectangle, right, is 3, but I need more than that to be able to get my final answer, right? Because what I need here is my base. And I'm not given my entire base. I'm given 2 offshoots of 2 and 1, and then there's this bit right here. Well, I do know what the length of this bit is because I know that it's 3, right? That's a square right up there. So I've got 3 plus 2 plus 1. That's going to give me 6. So my rectangle's area, right, is going to be 3 times 6, and that gives me 18 square yards. Now, what about for the circle? Because that semicircle on the bottom, there's 2 problems here. One, I'm not given the radius, right? And 2, I'm not given, well, what is it? It's not a circle, right? It's what we call a semicircle. That is half of a circle. So its area is going to be the same as a circle's area, but divided by 2. And again, I'm not given its radius, but I am given its diameter, the width across, right? That is 4. So that's going to be a radius of 2. Likewise, I could have given you this measurement, like I almost did at the start. That would have been 2, and that means that the height of the circle is 2, means its radius is 2 here, right? Because it's a semicircle. Okay, excellent. Now I just plug that in, right? So I get my area equals 4 pi divided by 2, so it's going to be 2 pi. So that's going to be 6.28 yards squared. But that's not my final answer. The last step here is to get all of these bits added together, right? So I need to add 9 and 18 and 6.28. And when I add those up, 9 plus 18 plus 6.28, I get a final answer of 27 plus 6 is 33, 33.28 yards squared. Okay, so obviously I only did it for one possible shape. How would you do this for other shapes? Well, any composite figure, you break it down into other figures, right? You do other figures put together to make that. So it's always the same basic steps. Step 1, identify what figures make up the shape. Step 2, find the area of each of those figures. And step 3, add those areas together. Now there is like a step 2A, which is once you know you need to find the areas, you need to find the measurements to get those areas, right? So you need to be given the base, you need to be given the height, you need to be given the radius. Sometimes, like with that red rectangle in the middle, right? I didn't give you the base straight away. You needed to get there logically by using other measurements provided to you in the problem and implying the measurement you're looking for. So you need to do some deduction, right? Pretty important part of geometry. There's another kind of composite figure. In this case, we added to get area, but what if I subtracted area? You might wonder, okay, how do you subtract an area, right? Well, allow me to show you, okay? So if I was to say, okay, I've got a cake here. Let me make a delicious looking cake, big old rectangular cake, right? And I'm gonna say, okay, I'm gonna take a slice out of this cake, and I'm a jerk. I'm gonna take a very ugly looking slice, right? I'm gonna take this slice out of the cake, okay? What is the area left over in the cake for other people to use after I did my jerk move here, right? So I want to find what's all this area that's left over after I took away my slice of cake, right? After I remove my slice of cake, what is left over? This is a version of a composite figure problem, right? Because what I'm trying to get is not really this rectangle bit, but the rectangle bit with this little bit taken out, right? To get that, I need to find the whole rectangle and I need to subtract the triangle, right? That's how I'm going to find the part left over. So let's break this down into, let's see it as one really big rectangle, right? And then our triangle that we're taking away, okay? Now, first of all, we need to find the area of what was the original shape that we were working with. Typically in a shaded region problem, it's going to be a basic figure, but not always, right? So here, what is the area of my original figure? Well, I would give you the measurements, right? I would say here it's going to be 4, 8. It's got a base of 8. It's got a height of 6. So the rectangle's area is going to be 8 times 6, just base times height, right? That's 48. And I'm going to say inches. That's pretty reasonable for a cake, right? So that's going to be inches squared. Now, what about for the triangle we took out? Well, remember, I might not give you every measurement for this, right? So I might say, this is the height, right? And I'm going to say that it's going to be 4. But then I might give you something like this. I might just go, oh, no, 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 I'm not going to give you that. I'm going to give you this. This is 1 right here, and this is 1 right here. Well, if I give you that, I'm taking away 1 from a 6. I'm taking away 1 from a 6, right? So you can figure out pretty quickly that the base is going to be 4, right? So it's not, again, you need to use a little bit of logic sometimes to figure out what measurements am I hiding from you, right? Not telling you directly that it's base of 4. You need to figure that out for yourself. So now I can find this because I got the height of 4 and the base of 4 that I figured out after knowing, well, I can't just do it just by knowing what's around it, right? That gives me my area is equal to base times height divided by 2, which is 16 divided by 2, which is 8 inches squared. So what do I do next? Well, I don't add them, right? Because my goal is not to get the entire thing. It's not to add another slice to the cake. It is to subtract a slice from the cake. So I need to take my answer right here and subtract 8 inches from it, right? So I'm going to do 48. Oh, whoopsies. I'm going to do 48 here minus 8 inches squared and get 40 inches squared is left over on the cake, okay? So with a shaded region problem, it's very similar, but instead of adding, you subtract, right? That is the major difference. You're taking away shapes from a larger shape, not adding shapes together to form a larger shape, okay? But both of them boil down to identify the useful figures you can construct, right? And then subtract the figures away to get the final figure you get. You don't need to see this as a composite figure problem, right? Where you'd be doing this rectangle, and then, this trapezoid right here, right? And then this trapezoid right here. That would be an awful composite figures problem. That'd be so many steps. It's much faster to see it as a shaded region problem, okay? There you are. That is how to do composite figures and shaded regions. So hopefully that helps. In our last video, which is our next one, I'm going to briefly review the Pythagorean theorems. I hope you look forward to that.